All right, guys, let's do number 43. An athlete throws a basketball upward from the ground, giving it an initial speed of 10.6 meters per second at an angle of 55 degrees above the horizontal. So let's draw this. Before we attempt to answer it, let's just kind of... All right, so this is kind of the motion here. And this is going to be the x-axis, and this is the y-axis. Anyways, and this is going to be the position as a function of time. I'm going to use my own notation. So I'm going to put x and y. X is going to be v naught cosine of theta naught times the time, and y is going to be v naught sine of theta naught times the time minus gt squared over 2. These are the basic standard parametric equation motions that we're going to be working with. So this guy is going to throw a basketball at some initial velocity, v naught, at some angle, theta naught. And this is going to be the component. So we're given the initial velocity. The initial velocity is going to be at 10.6 meters per second at the angle of theta naught. I'm going to define that to be 55 degrees. So there's the component, there's the motion. So let's keep reading. Now let's actually answer what they're asking. So the first step is just to get set up. All right, so let's answer part A. Part A is asking, what is the acceleration of the basketball at the highest point of its trajectory? Now, if you know your mathematics, folks, and you know your applied physics, then you'll know how to solve this. So the acceleration at the basketball at the highest point of its trajectory, that's when the final velocity in the y component is going to be 0. So that means that we're going to let y be 0, and that's going to be 0 to some initial velocity in the y direction, which is going to be v naught sine of theta minus gt. T is going to be v naught sine of theta naught divided by g. That's your time, and we're going to plug that time into either of these equations. Anyways, we didn't really need to do that because the question is asking what is the acceleration. The acceleration is always going to be pointing downward at 9.8 meters per second square. So that is the answer. So the acceleration is going to be 9.8 meters per second square. And I'm going to put a negative if you want. Actually, in this case, we might as well put that. So that's it. So that's part A. Part B is what is... On its way down, the basketball hits the rim at 3.505 meters above the floor. It bounces straight up, 1/2 the speed with which it hits the rim. What height above the floor does the basketball reach on this bounce? So now you have a situation where the basketball is going to bounce, and that bounce is going to I'm going to call that h, and h here is going to be 3.05 meters. For y to be h of v naught sine of theta naught, and once you find that time, you use the quadratic formula. You would say that t is going to be in 1.29 seconds. And once you find for that time, let's find the velocity in the y component that it hits the ground. So the velocity here, I'm going to define this to be Vy. And Vy is really just going to be, and I'm going to kind of cheat a little here because I want to get the positive magnitude. I'm going to say that this is going to be negative of V naught sine of theta naught. That's really just going to be 10.6 sine of, that's just going to be this component, even though I'm calling down negative in this case, minus or plus g of t. So that means that in this equation, positive is, down is positive and up is negative. Anyways, once you solve for that, your Vy would be approximately 3.95 meters per second. So that's basically saying that your motion for y is really just going to be the initial velocity in the y direction, t minus gt squared over 2. I'm going to call that y max, and we're going to let the output, the final component of the velocity in the y direction be 0 at some initial velocity in the y minus gt. So what we're going to be doing is we're going to isolate t, so that's going to be v naught y over g. All right, guys, I did do this problem correctly, so, but I was a bit confused. Not anymore. So the y max should indeed be 3.25 meters. That is the actual answer according to the way I have this set. Now, here's the thing with this problem, though. If you let v naught sine of theta naught be the actual 10.6 meters per second, so if you call that Vy and you use the quadratic form, your Vy, which is going to be half that speed, is going to be V naught sine of theta naught minus gt. And once you plug that in there, times 9.8 times that, this would be result into your Vy to be 7.25 meters per second. So once you put that, you should have 7.25 meters per second. Take a half, square root of that, divided by, is it just g or 2g? I think it's just 2g. This would result in, add that to that 3.05 meters. Add that to that. You should get, here, the actual answer is going to be 3.72 meters. Now, I say that because my answer, I have it as 3.25 the way I interpret this problem. Because it does say the speed at some angle. That implies that that's the magnitude of that directional speed, not the vertical. But I don't know how you guys interpret this, but that's how I interpret this originally. So this is going to be the solution manual. So anyways, folks, the actual solution is actually 3.72 meters. Because I did look at the solution manual and I was a bit confused, but that's only because the interpretation is a bit differently. Anyways, I hope this helps you guys, and goodbye.